Hi, today you are going to take a look at this aircraft indicator. This thing is a channel frequency indicator which was used in a Tornado aircraft ZE201. Okay, it was removed in 2012. So this thing should work normally. So this is a very small instrument. There is a dot matrix display. There is a push button here for selection between frequency and channel. On the rear there is a sub-D connector and there is a software part number here, revision 3. So you should find a microprocessor or a microcontroller inside. And here we have the part number of this item. Power supply input voltage 28 volts. Serial number 77, and this thing was manufactured in 2002. Okay, so we have a microcontroller. Oh, look at that, and there is a small DC-DC converter from Gaia, which is a French company, made in France. Now we have maybe an 8751. It is maybe possible to read the content or maybe not. I succeeded to read the previous 8751, but this one, I don't know if the security bit was set or not. Okay, it is possible we can see here 51. Yeah, bingo, it's effectively an 87C51. Okay, so we can see here another part, IS82C52. There is the crystal connected to that part. And here we have an ADC. And we have here a DS16F95. This is the power supply monitor. And here another DS16F95. Okay, so this is maybe a differential receiver. Okay, so the first thing I will do is to desolder this part. Unfortunately, it is not socketed. I will need to remove this part and see if I can read the content. Okay, so here we have filtering caps, 2 power resistors. So this diode is probably in series with the power supply. And we have here a TVS diode, 1N5555. Crystal frequency is 14.31818. Okay, we can see that we have effectively some parts on the bottom side. Okay, so we have several resistors, capacitors. We have here a decoder, a binary input to 8 outputs. I cannot read the reference of this part. Okay, so this part is an HC393. So this is a dual 4 bits counter. And we have here power transistor, maybe voltage regulator, maybe a MOSFET transistor. It was a little bit complicated to desolder this IC, and you can see that the code was not protected. So I succeeded to read the code of this microcontroller. You can see the binary file on the screen. Approximately 50% of the capacity of this microcontroller is used. Okay, so that is to say approximately 2 kilobytes. After that, I have used DSMX to disassemble the code. You can see that it is possible to disassemble various microprocessors, microcontrollers. And here we have the result of the disassembly. Okay, so the code is coherent. We have here the interrupt table. The start of code is here, and we have different interrupts. This one should be timer 0. We have here external interrupt number 1, I think, and here we have the communication interrupt. Okay, the start of code is here. There is the initialization of the stack pointer. So here we have the interrupt routines. Okay, so we have a return from interrupt here. So we can see this routine, for example. So I guess that we have here the timer interrupt. There is here another interrupt. And the first one is here. If you have to study the code, I suggest you to use a specific editor like this one. So I use Notepad++. It permits to have a syntactic coloration. Okay, so you can edit vertically. The next step will be to do the reverse engineering of the hardware. It is very difficult to study the code if you don't have some entry points. Entry points can be the communication interface, the display, push buttons, and other peripherals. We can see on the screen the schematic diagram of this unit. The microcontroller is in the center here. As you can see, we have two RS422 communication interfaces. One uses the internal UART. We can see the differential transceiver here. And the second one uses the external UART. We have also 3 digital inputs. The ADC is here, so this is an 8-bit ADC. You can see that the input can be connected either to VCC, either to one terminal of the connector. The selection is done by this jumper here. On the present configuration, the input is connected to VCC, so therefore the digital output here will be constant, close to full scale. I don't know the exact goal of this ADC. On the right, there is a frequency divider, which gives the frequency after calculation of 56 kHz approximately, which is fed to the display. So there is here another input. It seems connected to a test point. It is this pad. Okay, you can see here. So there is an address decoding, which gives 4 chip selects. 2 are used for the display, and there is also this MOSFET which is connected to the display, which can be activated by the firmware. The external UART uses this crystal at 5.0688 MHz. The processor itself has a clock of 14.31818 MHz. This is not a common frequency. We can see here the code for the UART interrupt. This interrupt corresponds to the internal UART interrupt, and there is another one which is external interrupt number 1, which is the interrupt of the external UART, but actually the code is absolutely identical. On that system there are 2 channels. One UART permits to display the frequency and the channel on one display, and the second UART permits to display another frequency and another channel to the other display. From the reverse engineering, I have found the protocol, which is here. 8 bytes should be sent to this instrument. One command starts by AA. After that, there are 2 bytes which are not used on this unit. After that, we have another code here, 7E. After that, there are 6 bytes for the frequency and 1 byte for the channel. Each byte is actually a BCD coding, therefore there are 2 digits per byte. We can see an example here. If you send this command AA 2 bytes 7E56341278, we will have on the display 123.456 for the frequency and CH78 for the channel. We can see here the start of the code. We have here the initialization code for both UART. So here we have the configuration of the internal UART. There is a function here which permits to set the baud rate. The baud rate of the internal UART is set to 14.91 kilobauds. So this is not the standard value. And we have here the initialization of the external UART, the 82C52. There are different registers. This register permits to set the baud rate. This register is a bitrate select register. There is a divisor here, 16/3, and a prescaler of 4. Using a crystal frequency of 5.068 here, we find a baud rate of 14.85 kilobauds, therefore close to the first one here. In order to test this indicator using a personal computer, it is better to change the crystal. For example, if we use a standard crystal of 4.9152 MHz, the baud rate becomes 14.4 kilobauds, which is the standard value. High-level language or assembly language. We can see that the code is not optimized. So here the value of 1 is fed to different registers in order to configure the display. One address corresponds to a particular digit. You can see that the register A is initialized with 1. You can see here that you have another initialization and one more and another one here. Okay, so this is not necessary because the register A doesn't change here. Okay, so we can remove these lines. Okay. We can see also here something which is a little bit ugly. This permits to write a string to the display. Therefore, 8 characters are written to the display. So for that there is a buffer and a pointer is incremented for each character. The pointer is initialized here because R7 corresponds actually to the pointer to the string to be displayed. But we can see that the pointer R1 here is added with 1 to get R1 plus 1. Normally we just need to increase the pointer R1. And the same here. Okay, it's better like that. Okay, so we can see something also which is not optimized here. So this is why I think that the code is a result of a compilation. Maybe a C compiler was used. For the test, I have connected these two inputs here to an RS-232 to RS-485 converter. We have two lines here which permit to enable both channels. So this line is connected to 28 volts power supply. So I discovered that this line permits to increase the luminosity of the display. So when this line is connected to ground, the luminosity is much higher. Okay, it is difficult to see, but we have plus characters here. Okay, so I can increase dramatically the luminosity. Okay. So now I will send a command. You can see that this thing works. You can see the transmitted command here. AA 2 bytes 7E, the frequency, okay, and the channel. So there is a particular case when bit 7 of this byte here is at high level, that is to say for value above 7. Okay, so I will replace 1 by 8. we can see that we have the letter A here, and we have different things concerning the frequency. We still have this letter A, so this is a special mode. I have discovered that this test point is actually a display test. Okay, so I will connect this pad to ground. Okay, you can see that all dots are activated. So I think it's a test for production. Okay, it should be also interesting to test this input here. So therefore I will desolder this 0 ohm resistor here, and I will solder it between these 2 points, and I will apply DC voltage at this input here. Okay, so roughly the voltage should be between 0 and 28 volts, because there is a divider by 5 approximately. Okay, so 0 to 28 volts. You should provide a variation here from 0 on that point to 5 volts approximately. Okay, so this line permits effectively to adjust the luminosity, but the luminosity is much lower than using this switch here. Okay, so this is the maximum luminosity when the voltage is 0 actually. If I increase the input voltage, you can see that the luminosity decreases. So here the voltage is 20 volts, 14. Okay, 0. This function is not used on this unit. Okay, so this switch permits to alternate between the night luminosity here and the day luminosity. So during the night luminosity, it is possible to adjust the luminosity. Okay, so using this input. Otherwise, when it is connected to VCC, the luminosity is minimum actually. On the present unit here, it is not possible to adjust the night luminosity. That's all for this indicator. Thank you for watching, and see you next time for another video. Bye bye.